one of the reasons that we learn linear algebra in math and also computer science because of the linear equation, and also discrete is also compulsory for the computer science majors to take, because there are so many things inside here that they use. Even the logic, the proof, if you don't master those two parts, then you cannot do so many things. Okay, now in the set theory, if you remember, in the set theory, we have union, right, between two sets. We have intersection in between two sets. We also have the complement, right? The set complement is the thing outside. Now, in here, in the we also have in the logic, the truth, right? You have this as O, this as N, right? And we use this as not, yeah? So we have union, intersection, complement, and we have O, N, and not. We have seen this before. Okay. Now, in this logic diagram, we have what we call the, well, this is the logic gate. Actually, I don't want to write that. Logic gates. This is in Malay. Gate is gate. There's a spell, gate is gate. But the logic gates, okay, the logic gates will be, the first one is the OR. Okay, with this logic gate, you go, some books, they use just one arrow, but I will use two arrows as the logic gates, and one arrow out. Two arrow in always, yeah, two arrow in and one arrow out. This is called the OR logic gate, right? The second one is the AND logic gate. So this one is still two arrow in, but like this. Okay, this is straight. This is like the moon. The third one is the NOT logic gate. So the NOT logic gate is two in, and then one out. Okay, there is a triangle and one out. Now we look at the, I will erase this, yeah, logic gates. Now we look at the logic table. So under this chapter, we will use a plus, yeah, a plus and Boolean numbers, zeros and ones, right? So the logic table, we start with X, Y, and then X plus Y. You remember last time we put true and false, right? So we will have 1, 1, 0, 0, 1, 0, 1, 0. Okay. So the plus is actually the OR, yeah? The plus, the dot, multiplication, and the prime. Okay, so the plus, as long as you see a 1, then you get a 1. Okay, it's like the OR. All right, and then the N, is only one if both are one, right? Okay. And then the prime. I can put here. Okay, 1, 0. The prime is 0, 1. So instead of true, false, we write in terms of ones and zeros. Okay. Now look at the Boolean expression. What does it mean by Boolean expressions? At this level, degree in a university, right? You don't just base your knowledge on the lecture notes. You have to find at least a textbook, a reference book under discrete math. Then you read through, because in the book, in the textbook, they write the story in more details, description, more examples. You have to do more exercises. That is how you learn, not only depending on the class or the class notes or the class exercises. Yeah, that's why if I give you something totally different from the examples or the exercise in the notes, you cannot answer because you have not seen it before, because you have not referred to other books. Okay, so Boolean expressions I use the symbols in the symbols of x1, x2 until xn are defined recursively as follows. Okay. We have 0, 1, x1, x2 until xn. You see how we put this expression. So these are Boolean expressions. If capital X and capital Y are Boolean expressions, then X, Y bar, X or Y, X and Y are also Boolean expressions. Then we also have Boolean polynomials. Okay, Boolean polynomials. Let x1, x2 until xn be a set of n variables or symbols. Okay, a Boolean polynomial P in terms of this x. We write polynomial like f of xy, p xy, like this, right? Is defined as follows. X1, X2, and or Xn are Boolean expressions coming from here. And 0 and 1 are Boolean polynomials. If we have P and Q, I call it BP, bukan gas station. If they are Boolean polynomials, then so are the O and the N and the prime, or the Q prime. Yeah. Okay. What is that Boolean expression and Boolean polynomial? Let me give an example. Okay. All right. It's actually like a polynomial, but in terms of expression like X, Y, with zeros and ones as the right. Okay, so examples of Boolean expression. Okay. Number 1, P X Y Z equal X prime Y plus Z. Okay, so the operation is a times here, right? There's a prime, there's a dot, there's a plus. Okay. Second one, Q X Y Z X prime plus Y dot Z. Okay. The third one, R X Y Z X plus Y plus Z dot Z prime. Okay, then from a given expression, later on we will have a Boolean function. We want to draw a logic network. Okay, we want to draw a logic network. Before we draw that, let's do the table, yeah? Okay, let me first go to the second definition. I don't want to erase this because I want to draw the logic diagram later. Okay, but before that, let me draw write a definition of Boolean function. Okay. I will stop at 12:15 and then 5-minute break, and then I will read through the quiz 12:20 and give you time 12:30 we start the quiz until 12:45. Okay, and then I will give you 15 minutes to upload. Should be 1 or 2 pages. Should be kacang pun susah nak gigit. Very easy. Okay, just a exercise for you. Okay, what is a Boolean function? Let x in terms of this x1, x2, xn be a Boolean expression. A function of the form f of x1, x2 until xn, which is equal to this. Okay, is called a Boolean function. You don't really see the difference because we take a mapping, that's why it's a function, from one to another. Okay, and this expression is in terms like this, right? So instead of we put Boolean expression in this way, we call this a function from B cross B or B cross B cross B, depending on how many variables that you have. Okay, let's see. First example. Okay. F from B squared to B. Okay. F of xy is x plus y. Okay. So just now we have seen this, right? We have seen xy, x plus y, right? This is the truth table that we have seen before. So actually this f, the domain of f is the set of 1, 1, 1, 0, 0, 1, 0, 0, right? That's the B squared, okay? And when you want to write the mapping, here we write f of 1, 1 is 1, f of 1, 0 is 1, f of 0, 1 is 1, f of 0, 0 is 0. Okay, you don't write 1 plus 1 equal 2, although it's x plus y, right? Because that is how the truth table is. It's not the 1 plus 1 equals 2. So like one in binary is equal to 0. No, don't get confused with the real plus, because this is the Boolean, okay, or. And the n is the same thing. So I'm not going to go to the n. And this table is, you know, it's called the truth table. All right. You might be given another question like this. Find the truth table of this Boolean function. Okay. So I will change. F of B3 into B. Get ready. F of x, y, z is equal to x prime y plus z. Okay, show me the truth table. So 3 of them, 2 to the 3, you will have 8 rows, right? 8 rows. So you have X, Y, Z. So you have all this, then 2, then 1. Right? It feels different, right? If you look at the already notes already, I just showed it this rather than looking and writing and copying. It feels different, right? Okay. So now we need to have X prime, yeah? X prime. And then we need to have X prime dot Y. And then we have X prime dot Y plus Z. Okay. X prime is 0, 0, 0, 0, 1, 1, 1, 1. Make sure your answer is to the most right. To the most right. I'm saying this, ada yang jawapan kat tengah-tengah, so I couldn't see. You have to follow the question and your final answer should be at the most right. Okay, so X prime dot Y, dot only one if both are 1. Dot X prime dot Y. There's a 0, 0, because these are all zeros, so I don't even look here. I just look here, they're all zeros. Okay, now there's a 1, 1, 0, 0, right? X prime Y. And then this is a plus. So you just see this and this, right? This and this. You want a plus. Okay. 1, 0, 1, 0, 1, 1, 1, 0. Okay. There are other examples that you can go through. Okay, when you get the notes, it's very similar to this. Just an exercise for you to understand, go through, but don't look at the notes. Try to write out and then compare whether you get the same answer. Okay, now we want to draw the logic network of this. So I will start with putting in X, Y, Z. Okay, X, Y, Z. Some books, they draw it differently, whether the going in 2 or going in 1. But for the first operation that you do, I will do going in twice, yeah, the 2 arrows in. So we need to start with X prime. So I will need 2 of this, and then this becomes the prime. Okay, go ahead, start with that. And then the next one is I need to multiply by Y. So you remember the multiplication, right? So I need the Y to be closer, right? So I can do like this. Right? So this is the Y, X prime and Y. So the one outside is X prime times 1. And then I need a plus Z. So bring the Z here, but not one from here and you will make like very big. So bring it closer like this. So this is still Z, right? And then x prime dot y plus z. This is the logic network of this. Okay, now try number 2 and 3. Let us compare our answer. Okay, let's go together. Number 2. So we have again, 2 for x. 2 for x. Because there's a x prime. Then there's a y. And then there's a z. Sometimes I was asked, can we put x, z, y? Okay. If you put the always x, y, z, okay, then z you can go up, right? But I normally will put x, y, z to be consistent. All right, and now you have to do x prime. This is x prime. Then you have to do plus y. So you bring the y closer like this, and then you do straight. So this is x prime plus y. Okay, and then you want to multiply by z. So you bring this, right? Then this multiply by z. Right? 3. Wow, panjang. So this one is x, y, z. But the x is at the end, right? This is at the end. You actually have to do this first, right? Y plus z. Because it's actually commutative also. X plus y is y plus x. So you will do y plus z first. So make it closer. Plus, right? So this is y plus z. And then you need to multiply by z. You cannot put z again. Don't write another z down there. But you can pull down. Okay, pull down and do a z here. Like this. This is a z in. Yeah. Okay. Then you can do the z prime. Okay, it comes from the z. Then you can do together. Then there is a plus. It's not a plus. It's a multiplication, sorry. It's multiplication. Okay. You haven't finished yet because we need an x plus. So you can bring this close. Either you go here or you go up. Doesn't matter, yeah? I just go up like this. Yeah. And then it's a and then it's a plus. Okay. So this is x plus y plus z dot z. So your drawing can be a little bit different from your friend in terms of maybe this one is here a little bit, right? This one is to the right a little bit. So there is no specific rule how far or whether they have to be directly under, right? Or this one, whether you have to bring and continue here or you take the middle. It depends. Doesn't have to be. So, but sometimes people normally will continue to the right to the middle. So if you see some books, they want it to be in the middle. So this go down a little bit, but it's okay. All right. Now, next definition is okay, ya? Okay. Soalan tu? Okay, Fatana. Okay. Let me see. Page 2. Okay tak okay ni? Ada arrow, ada jempol ke bawah? Ada kalau tak okay. Okay, I see all okay. Right. Next, I introduce. Actually, I really like this chapter. Ever since I took this class so many years ago, I like this chapter because I can draw, right? I like the class. Okay. Next definition is called the min-term canonical form. Okay, sometimes in the question, you are asked to rewrite the Boolean expression in terms of min-term canonical form. So you have to know what it means. Okay. The min-term canonical form is actually, we join all expression. Sometimes you are given not the min-term. You have the Boolean D in terms of X, Y, Z. But sometimes the expression is given for just a few X and Y. There is no X, Y, Z. So you want to do expression in terms of the summation of the product of in terms of X, Y, Z. But the formal definition did not really show that way, but let me just write it out. Okay, we call the join of min terms equivalent to a given Boolean expression E, the min term canonical form of E. So E is the expression. Okay. The join of all the terms in the Boolean. So let's try to see with an example. F of X, Y, Z equal X, Y prime plus Z. Okay. So what we do, this is not in terms of x, y, z. It's not the sum of all the terms of x, y, z. You have to write it in terms of the sum of all the possible terms of x, y, z. All right. So let's draw first the truth table. X, Y, Z. Okay, then we need the Y prime. Then we need X, Y prime. Right? Only one has one. Okay, the rest is 0. And then last one. Right? You just compare this. That is 1. You put 1, 1, 1, 1, 0. Okay, so from this, then you have 1, 2, 3, 4, 5. So your mean term, canonical form for x, y, z equal, so you just take this one. Is the sum of the value in this expression. So this one, you take x, y, z. For the first one. For this one, x, y prime, z. Okay, for this one, x, y prime, z. For this one, x, y prime, z prime. For this one, take 1, 2, 3, 4. X prime, y, z. X prime, y, z. Last one, x prime, y prime, z. There is another example that you can do, yeah? Okay. Imagine you have to do the logic diagram, the logic diagram we did earlier. But it can still be done, but you will have like how many, right? You have 1, 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If you do, there will be 20 of those things. Okay. Tak bagilah soalan sampai 20 ni. Nak semak pun pening. Okay, now equivalent. How do we say two Boolean expressions are equivalent? They are equivalent provided their corresponding Boolean functions are the same. Okay? Meaning, just now, this and this, they are equivalent, right? This and this, they're equivalent. They even have the same truth table. All right, okay. Now next is the Boolean algebras. Boolean algebras. All right. Okay. Now, a Boolean algebra is a set with two binary operations. Is a set with two binary operations. Plus and the multiplication dot. A unary operation prime and distinct elements zero and one. We always talk about the binary numbers, right? 0 and 1 for X, Y, Z in B. It's a set with two binary operation. Binary means you have to have two, right? To add or to multiply. Unary, you just need one X and then take the prime and the distinct elements. Okay. Now, look at the properties of this Boolean algebra. This is very important because later you have to prove that something are equivalent. You can derive from one expression to another, and you have to know these properties. Okay. Properties of Boolean algebra. Okay. Now, so I write the properties here. Okay. And I will compare with this. Okay, Shiham, later on you help me to change the column, yeah? The first one is what we call a commutative. I think you have seen this so many times, right? X plus Y is Y plus X. Like numbers are commutative, matrices are commutative under addition, right? And it also is commutative for this one. The next one is associative. So this is X plus Y plus Z is X plus Y plus Z. And for this one, X dot Y dot Z is X dot Y dot Z. And then distributive. This is a little bit different for the plus. X plus yz is x plus y, x plus z. But if we have the original like this is x dot y plus x dot z. For identity, under addition, x plus 0 is x. X times 1 is x. You might wonder what is x times x, right? What is x times x? Right? Because x times x is 1 is 0, right? Which is actually x. So x times x is x. What is x plus x? If this 1, 1 is 1, 0, 0 is 0. So x plus x is also x. It's weird. We have x is 1, 0. Another x is still 1, 0. So if you multiply x and x, multiply is both 1 is 1, right? So 1, 1, 1, 0, 0, 0. And addition, you have to have at least 1 to get 1. So, which is actually, so that comes next, yeah? Complement and idempotent. This one is the idempotent one. X plus x is x, x times x is x. What is x plus x prime? X prime. 0, 1. So when you add, it's always 1. And when you multiply, it's always different, right? The other way. So, okay. So we have complete properties of Boolean algebra. You can check this. Sometimes x times x plus x times z plus y times x plus y times z. Okay, and you think about where did this go, right? You can just, because you only have x plus yz, right? But that is the identity. If you want to try to find the reason, you can find the reason. Okay, this can be shown by the truth table. Okay, so next, what are we going to do? Okay, next we look at De Morgan's law, some other law that is not put under the properties of Boolean algebra, but we can use that for proving some identities or to show some Boolean expressions are the same. Okay. Okay. De Morgan's law. Right? So De Morgan's law give first for the prime. You remember De Morgan's law for set, right? So it's very similar. A union B prime is A prime intersect B prime. So that's De Morgan's law for set. So De Morgan's law for Boolean is x plus y prime is x prime y prime. That is a dot, right? Like the intersection becomes a union, so the plus becomes the dot. If you have xy, x times y prime, though this becomes x prime plus y prime. All right. And what happens if you take prime twice? This becomes just x, right? You take the prime twice, it becomes just x. Okay, now this is the question that will be asked. Simplify this following Boolean expression using the properties. So you have to simplify the following Boolean expression. So for the first one, simplify xy plus x prime y. Okay, so you will use the distributive law, right? So xy prime plus x prime y. What do you do? Yesterday I called Alia, right? Today I want to call Muhammad Atif. Atif, are you here?
Hello. Ada, Prof.
Ada, okay. How do you distribute this? Using the distributive property? How do you distribute? So you take the y, right?
Y.
The right. And what's left? X plus
X prime.
X prime. And what is X plus X prime?
1.
1.
Equal
So
to
what
1.
is 1 times y?
Y.
Y. Kan?
Yeah.
So you want to simplify these two expressions, and at the end it's just very simple. It's just y. So the question, sometimes they said simplify this. That's it. Sometimes they said, dia tu saya lah nanti kan bagi soalan. Simplify this and show that this is equal to this. So somehow depends. It's better you are given a hint, right? To simplify this and you get that one. Okay, try this next question, yeah? The next one is simplify y plus y prime to get y plus 1. The trick skit, okay? How can you simplify y plus y prime and then you get there is a y but there is a 1? So what you will do is actually a trick in which you write y, because you need a y, right? Then y plus y is equal to y plus y, right? Y is equal to y plus y. So just replace this y with y plus y, right? Y prime, you just write that. Why do I do this? Because I want to do the associative, right? Associative is y plus y plus y prime. And what is y plus y prime? 1. So this is equal to y plus 1. So sometimes you have to create, depending on the question given, you have to create something which is not there, like this. Y is just y plus y. Because you want to have this y, combine this to get the 1 at the back. All right. Okay. There are some other examples. Okay, one more. One more. So it is this. Number 3. Okay, x plus x prime y equal x plus y. How can you just diminish the x prime? Right? So what you do? What you will do is using distributive. You see, x plus x prime y is x plus x prime, x plus x prime times x plus y. This one. Right? So I just compare x plus x prime y with this, x plus x prime y, right? So you take x plus y, which is x plus x prime, then you take x plus z. X plus z is x plus y. And what is x plus x prime? Is equal to 1 x plus y, and 1 times x plus y is x plus y. Okay. All right. This is something that you have to do with later on help by Kano map. Okay, but before we do the Kano map, we do this first. How do you reduce a very long equation into a simplified one? Okay. X, Y, Z plus X, Y prime Z plus X, Y prime Z prime plus X prime Y prime Z plus X prime Y prime Z prime into XYZ plus XY prime Z plus XY prime Z prime plus X prime Y prime Z plus X prime Y prime Z prime. So XYZ, SY prime Z. All right. If you don't use Kano map, you want to combine and use distributive law, okay? But you have to have a pair to factor out some terms. This one, you have 1, 2, 3, 4, 5. Okay, so you don't have enough. So what I will give you is to add another term because x plus x is x. I can add another term. Without the known method of Carnot map, this would be hard, but let me show you this first. Okay, so I create x, y, z is the same. X, y prime z is the same. I group. And then I create x, y prime z. It's not there. Okay, but these two equal plus is equal. I just create this so I can pair with this. Right? And then the last one. Now they have pair. Why do I need this pair? Because from here I can take out x here, y plus y prime z, right? X, z, z, take out. This one, x, y prime. X prime, oops, sorry. X prime, y prime. Right? So you take out whatever factor, common factor. And then you use the fact that z plus z prime, x plus x prime is 1. Yeah? 1, right? So x times 1 times z is just x, z, x, y prime, x prime, y prime, because this is equal to 1. Okay. And then you see this one is common, so you take out x prime, and then you get this. So this is 1, right? So xz plus this is the y prime. 1 times y prime is y prime. Ada dah jawapan kat sini. Just how do you get to that answer? Okay. How do I know what to add? Okay, how do I know what to add? This is how we use the, what we call the Carnot map. Okay. So for the Carnot map, if you have the table depends on how you draw the table, but for the xy, normally we put xy prime, x prime, y prime. So this is xx, y prime, x prime, y, x prime, y prime. Sometimes it change. Let me just follow the book. Okay, it doesn't matter actually, but be consistent. Yeah. So I will do consistently x y prime, x prime, y prime, x prime, y. And you fill out x, y, z, x, y, z, x, y prime, z, x, y prime, z, x, y prime, z prime, x, y prime, z prime, x prime, y prime, z, x prime, y prime, z. Okay. So Carnot map is actually a method for minimizing a Boolean expression. The resemblance is like the Venn diagram. This is Carnot map. Minimizing Boolean expression. Okay. But only when there are like 3 variables, 4 variables. If there are too many variables, then normally people won't use this anymore. It's too big. Okay. Now the input is like if you have 2 input, I will do this later, yeah? Let me do the Carnot map first. if you have the two input, so the x prime or y prime x. Okay. If you have three input, it will be like this. Sometimes people don't put the outside box, but I used to put the outside. You can just do the inside and write it. And sometimes people put another one outside, but it's okay. For the 4 input, so wx prime, w prime x prime, w prime x. The same thing, yz prime, y prime z prime, y prime z. Okay, so we normally stop just at this 4. Okay, and how do you do this? What do you do this? Now, if you have in the terms, you put a 1. Okay, you put a 1. That's the first thing. You put a 1. But you don't put the 0, right? And then you start doing a circle. Okay, you start doing a circle. 2 or 4 or 8 is a power of 2. What is the biggest circle you can draw and group? You can draw and group to make sure that everyone is circled, right? So what you will do is you draw a circle. What is the largest circle here? 4, right? This one. You can draw a circle. Okay, remember, this is like a cylinder. If you have one here, you can put together, this is cylinder, yeah? What happened to this one? This one has to be circled and it has to be 2. 2, 4, 8, so you have to circle for that one. And that is why we know there's a double here. Alah, terpadam pula. That is why I know that I can add another xy prime z to make it simple. Okay, and from this, how do we read this? Okay, this circle here, it covers z prime. So it's 1, right? This circle here, it covers x prime. Okay, the only thing that it does not cover is the y, it's y prime, right? So this one is actually just y prime. Because that circle cover z prime covered, x prime covered, but only y prime. So this is y prime. And what is this one cover? This one cover x, y prime, already 1, right? Y prime covered, so x and z. So that is why you have, from the Carnot map, the answer is xz plus y prime. All right. Okay, so you can try. There are actually many examples. Okay. Sometimes they give the mean canonical terms. You have to write the truth table, and then you have to find the simplest or the minimum expression. Remember, just now we calculate the gates, there are 20 gates, but that 20 gates can be minimized into like this, only 1, 2, 3 gates, right? 3 gates. 1, 2, 3 gates. From like 20 gates, you can minimize to 3 gates. And then you have to draw the logic gates. This will give like 20 marks ke kalau final kan. You just give an expression, write out the truth table, and then show using properties how this can be simplified, and show using Kano map, and draw the logic gates. Yeah, 20/100. Okay, I think you can I give you one question. So you can try, not now. And when we meet again, after I come back, okay? So I will also pass you the notes, maybe next week. Okay, I give you one question. Yeah? Okay. Exercise. F of x, y, z equal x, y, z plus x, y, z prime plus x, y prime, z plus x, y prime, z prime plus x prime, y, z. X, y, z plus x, y, z prime plus x, y prime, z plus x, y prime, z prime plus x prime, y, z. Okay, 1, 2, 3, 4, 5. Okay. So the first question is, do the Kano map. Number 2, find the minimum expression. Third one is, draw the logic gates. Okay, all right. Okay, any question? I practically finished. You can read through nor and none. Okay. 5. Okay. Okay.